Alright, this is the tutorial for the final unit of practice problems for Physical Science A final exam. So this is the energy unit. As always, recommendation, have a calculator formula sheet, pause me every once in a while, make sure that you can work through it on your own. So, LT1 is I can calculate work. We know that work is the product of exerting a force over a distance. That force must cause movement. So, 200 joules of work is done to move a load up 1 story. What if we were going to move the same load up 4 stories? This is just kind of a simple thought process here. If it takes 200 joules to move a load up 1, then to move a load up 4 stories, it would just be 4 times as much. So 200 multiplied by 4 gives us 800 joules of work. Remember, the units for work could also be a Newton meter. So a Newton meter or a joule. Number 2, 15 Newton force is applied to move an object 6 meters. Calculate work. So work is just going to be the force multiplied by the distance, and 15 multiplied by 6. So very straightforward, 90 joules. Number 3, how many joules of work is required to carry a 10 Newton paint can 8 meters up a flight of stairs? Newtons is a force, meters is a distance, work is 10 times 8. 80 joules of work. Alright, so those are all pretty straightforward. Just don't let me get in your head. If I talk to you about moving an object, not moving an object. If I say exert a force of 10,000 newtons trying to push an elephant, but the elephant won't move, if there is no movement in the direction of the exerted force, remember, no work is done. So I might give you some fancy numbers, but if you see that no movement occurs, there is no work being done. Number 2, LT2 here, power. Power, remember, a couple different formulas. It's work divided by time, and that would be the same thing as it's the force multiplied by the distance, because that is work divided by time. So the only difference between power and work is this time factor. Now we care about how quickly work is done or how slowly work is done. So we'll start out very simple. 2,000 joules of work are done lifting an object above a person's head in 1.5 seconds. Looking for the power output. I already gave you the work and you have a time. So it's going to be 2,000 divided by 1.5. So we're going to go 2,000. That looks like 20,000. 2,000, there we go. Divided by 1.5. Answer is, we're going to round to the 10th, which means we keep this spot, and the 3 to the right says you will stay a 3. You will not bump up to a 4. So 1,333.3 watts, because watts are the unit for power. Number 5 is more the thinking thing, all right, more of a thought process. If you start and it takes you 100 watts of, this should say power, my fault there, I need to fix that. 100 watts of power to do 20 push-ups in 15 seconds. How much power then to do 20 in 30 seconds? So the thought process is, if it takes somebody longer to do the same amount of work, they are less powerful. They're using less power. If somebody can do the same amount of work in a shorter amount of time, they are more powerful. So if we have our 100 watts, okay, that's our original power, and then we have 15 seconds and 30 seconds. Remember, our first step was to compare the times. So 30 seconds compared to 15 seconds is 2. So it takes this person 2 times longer to do the push-ups. If it's 2 times longer, that is going to be half the power. Okay, half the power then would be 50 watts. Okay, so compare our times, look at our original power, it would be half. Now if I flip this on you and said, oh, somebody can do 20 push-ups in 7.5 seconds, where they did it in half the time, well, now all of a sudden you are more powerful. So we would take that original power and multiply it by 2. All right, so stop yourself at the end of these types of problems. If it takes somebody longer, we should have a smaller power output. If somebody does it faster, we should have a greater power output. Number 6, how many watts of power? Looking for power again. We have a force, 16 newtons. We have a distance, 5 meters. we have a time. Okay, so looking at formula sheet, we know it's force times distance divided by time. So it's 16 times 5 divided by 2.25. So 16 times 5, and then we divide it by 2.25. Answer is 35 point. We're going to round to the 10th. This is 5 or above. Therefore, it's going to be 35.6. That will bump up the 10th place. So 35.6 watts. 35.6 watts. All right, kinetic energy, potential energy. The two I put on here are the simplistic ones. All right, make sure you do remember. So you may want to go back through your old learning targets. And what if you had to solve for velocity? All right, so go back and look at some of those. There's practice problems online. What if you had to solve for velocity? What if you had to solve for height? All right, so that's just a helpful hint. Go back through some of the old stuff. I just put a couple of the kind of quick and simple ones on here. Number 7, we know I'm going to write it down here. Potential energy is always mass times gravity times height, and gravity on Earth is 10. All right, we have that on our formula sheet. So for number 7, we're going to take the 3. There's our mass. We're going to multiply gravity, which is 10. We're going to multiply the height, which is 12. So 12 times 10 is 120. 120 times 3 would be 360 joules of energy. All right, 360 joules. So the biggest mistake people make on this is they see this and they're like, oh yeah, potential, I multiply them. Don't forget about good old gravity. It's kind of a big deal. All right, so don't forget about that. Number 8, kinetic energy. Kinetic energy, remember, is 1/2 mv squared. So we're looking for the kinetic energy where we have half. The mass is 2,500 of this airplane, and the velocity is 500 squared. Number 1 mistake, you only square the velocity. That has to happen first. So we're going to go 500, caret 2, and hit enter. Then we multiply it by 2,500, and then it's going to be half of that. So I just always go times 0.5. You could divide it by 2, however you want to look at that. So big number, but it should be a big number. It's an airplane. They're kind of big and they're kind of fast. So what do we have? 5 zeros. 3, 4, 5. So what is this thing? 312,500,000 joules of kinetic energy. Just a friendly reminder, you do not type in commas into Moodle. It will yell at you. It'll give you a red error. Okay, so you would just type in the digits and never units. Again, like I said at the beginning, go back and check out, like, if I had given you the kinetic energy over here and you had to solve for velocity, make sure you could do that. All right, so here's what it would look like even. If here's the kinetic energy, let's say we started with that. So here's a perk to somebody that's actually listening to this video. And like, make sure you can solve that. So remember, we would take half of 2,500, which is 1,250. So it would be this number. Then we would divide by 1,250. Okay, hopefully this is coming back. And then you would take the square root of each side. All right, so the answer is going to end up being 500 because I just kind of flipped this problem on end. But make sure you can do that. All right, now you know how to take the square root on a calculator and all that good fun stuff. All right, good luck.